Okay, so I have put the link to these slides also under resources on Piazza, so you would have all the slides there. It's basically a Google Doc. Just want to walk through. There are like some 25 odd projects. Obviously, I will not go in detail, but it should get you the sense of, well, firstly, these are some specific projects with willing mentors, but the other thing is it should just give you a sense of kind of topics you can be thinking about and potentially come up with your own project ideas. Okay, so first one is embedded AI or embedded machine learning on embed, but kind of the thrust out here is that there's a lot of interest now on doing processing of sensor data or doing control of actuators using not traditional EE type signal processing and control, but kind of using modern, more CS oriented methods that have emerged as part of machine learning. Essentially, these are more data driven type algorithms, and neural networks are kind of an example of that. So what this project explores is there's some software which has begun to emerge for doing implementations of neural nets, and I think some of the students in the class are doing Professor Jonathan Cow's course. I don't know, anyone of you doing it? Yeah, okay, 1, 2, okay. So being able to realize them on edge devices, in particular extremely resource constrained edge devices like the microcontrollers type things. So it so happens that ST Microelectronics, which is the company making some of these embed boards, they have released a tool called STM32Cube.ai. STM32 is just 32-bit STM MCUs. Cube.ai, I don't know what AI means. AI, I don't know what the cube is for. But in any case, basically, you can synthesize code for deep neural networks optimized for microcontroller type devices. So, and likewise, ARM has also created a library for doing these kind of things. And then, of course, you can attempt to use some of the lighter weight neural networks which are out there. So there are a couple of ways you can approach projects in this space. One is more on like a comparison of either different software or different MCUs and all. But the one I have cited out here is that perhaps implement a DNN, a deep neural network, for some specific task, let's say human activity recognition. So these are systems which seek to infer something about what a person is doing using data from, let's say, accelerometers or gyros or something, things like that. But you can also imagine a camera attached to one of these devices or a sound sensor attached to these devices, and but then using one of these tools such as the STM tool, kind of go through the whole chain and then characterize the performance and perhaps compare it against what would it have meant if you had taken the data and done it on a Raspberry Pi or done it on a cloud server, for example. I guess ideally this is some, I mean, you would need to know obviously here's something about deep neural networks, so either you should already know or be willing to learn about it, or perhaps one of the courses, if you're taking concurrently that other course. There's a fair bit of expertise in this space in my group, so we can certainly mentor you quite a bit on that. Related project, oh, by the way, feel free to interrupt and ask, otherwise, since I have around 2 minutes per project. Huh? What does what? Oh, what do the mentors do? Depends on the project, but basically at the very least help sanity check in terms of is it too ambitious or too simple, and then also arrange if the project needs some hardware resources, then we'll buy it for you, but so kind of just coordinating that, and finally kind of just pointing you to the right places. But the mentor will not, the role of the mentor is not to spoon feed you. Okay, so it's not going to be do this, do that. That is your goal. You have to define it, but we'll give you the guidance and the right path. Okay, so I think projects like these are more fun if you are not just being a pair of hands implementing something that your mentor is doing, but rather you're bringing your own ideas to the table and good stuff. So that's the role of mentors. Okay. Project 2 is kind of the same space, except that in this particular case, there is a company called Greenwave Technologies, and they have come out with a platform called GAP 8, which is an IoT platform, kind of like your Raspberry Pi and all, but it's specifically optimized for running signal processing and machine learning type workloads. So the kind of the idea here would be use that platform and again kind of go through the similar exercise and perhaps compare how I mean, again, a few different ways you can define this project. One is just focusing on GAP 8, kind of create a complete thing, particularly perhaps for some interesting modality like sound from a microphone or sort of images coming from a camera or some other type of sensor data. Or the other possibility is you can do a comparison of same thing across different options that currently exist for edge platforms. So we certainly have the MCUs type things. First project, you can certainly run like TensorFlow, which is Google's software for neural networks. It can run on Raspberry Pi, so that can be a second comparison point. A third comparison, then you obviously have GAP 8. Intel makes a USB stick called Movidius. You can compare against that and compare both in multiple dimensions, like how much memory, what's the speed, how does the speed scale. So it could also be that for small networks, maybe they are all the same, but for larger networks, one of them begins to shine. So there are various spins on this basic project idea that you can do, and that's kind of what this project 3 is saying, that you kind of do the comparison. Another interesting dimension to take here is not simply inferencing. So inferencing refers to, I have the data, I already have the model which I have trained previously, and I'm just computing something based upon that model. But then there is other part, learning, which is I have devices out there, they are collecting data, and I'm learning a model on it. Learning is a lot more compute intensive, and so project 3 in part is saying learning. So imagine a bunch of IoT devices in your home, they're observing data. Maybe in some initial phase we also provide necessary labels to help do the training, or maybe you are doing what is called as unsupervised learning, but across this collection of devices, learn a model as opposed to simply executing a model, which is what project 1 and 2 are kind of focusing on. So what I would like to bring out across these projects is that there is a space of ideas you could explore, or you can build a project on one of those things in this machine learning on resource constrained edge devices. There are so most of these platforms that I'm talking about we already have, so there is no new hardware to buy. In terms of measuring speed, that's something that you just have to figure out. And since measuring speed, measuring power, we have the appropriate things in my lab, so you'll have to come to the lab and do that measurement. You would need to be somewhat handy with working with test instruments, that is hooking up the hardware to it so that you can make the measurements. So there have been sort of variety of papers in recent times on looking at machine learning on these edge devices. We have cited some out here. Federated learning is work out of Google. This is out of my lab. There's a couple of others. They're looking at different facets. Okay, so once you begin to discuss with me, and you would see Sandeep's name appear again and again. So we too are probably your resources. Come and talk to us. And what I would like to do is that if multiple teams are interested in the space, I want to have distinct projects. Okay, I don't want multiple teams doing exactly the same thing. Firstly, it becomes boring. But the other thing is it actually puts you at a disadvantage, because if two teams are doing the same project, and let's say one team does better than the other, guess what? I mean, it's right. On the other hand, if you're doing two different things, then you're just competing against yourself. So pick different things. So my strategy there would be kind of two-pronged. If I'm convinced that one team has its act together and is clearly going to do a better job, then that team will get the project. And if that's not the case, two teams are similar, then first come, first served. Okay. Building upon that theme, there's one more project. So adapting CNN, convolutional neural networks, to wireless link. So kind of the idea now is that if I'm doing either inferencing or learning, but in this case I meant inferencing. So I have a model with a neural network made of multiple layers of neurons, and I could either run it all on the edge device, I could run it all on a cloud server, or I can split the model between the two. And also I can have choices of models of different accuracy complexity, and then there are ways you can run model like when I say choices can be in multiple dimensions. One could be totally different neural network architecture, but the other could be kind of the same model, but perhaps one is integer, the other is 16-bit floating point, and the third one is 32-bit floating point, and they will have very different performances. So so the idea out here is that create adaptive neural networks or an adaptive inferencing layer which adapts to the condition of the wireless link. Okay, so wireless links change their characteristics because of other traffic, because of the distance between the two radios, or maybe simply what is available. Like for example, sometime your phone is on Wi-Fi network, and at other times it's on cellular network. Sometimes it has LTE, sometimes it has 3G. So in response to those changes, how would you adapt this? Because you can as you can imagine, if I have a very high rate link, then perhaps I can simply send the data to the other side and have it be evaluated out there. And if on the other hand I'm on an extremely resource constrained link, then perhaps doing local computation is better. Same trade-off will also occur between your smartwatch type devices and your smartphone. Essentially the same story. So you can explore this project in either context. So kind of this general theme of adapting the computation. Next one, Alexa on wheels. So I'm sure everyone knows Alexa, or you can replace it by whatever, Google Assistant or Siri or whatnot. But kind of basic idea out here is that there's a lot of interest in creating devices which are not simply you can set an alarm or play a clock and all, but a lot of people think that these kind of devices would have a role to play for assisting elderly people and kind of people who are disabled and things like that. So these kind of personal robots can play a role out there. Moreover, these devices can act as kind of like pets. They could be like family members which are keeping an eye. They could be kind of like assistants who could be tasked and all. So the notion out here is since some of these systems allow for augmenting them with your own code or writing enhanced skills and all, so could we create some simple version out here by mating these capabilities with a wheel robot which perhaps can follow, keep an eye, so maybe it has a camera and kind of keep an eye on the person, or just interact with it. So kind of explore the space out there. Amazon, the reason I picked Alexa is because it's probably the more open of the three platforms, so there are a lot of resources. And also there's a company called Matrix Creator which creates a totally open source stack. Open source hardware is basically board with multiple speakers which connects to Raspberry Pi, and then kind of they have a whole software ecosystem. So there are a variety of things you can do. So in addition to obviously the voice in out capability, you can have some sensors on that mobile platform, and again mobile robot part is relatively straightforward in the sense there are plenty of mobile robot platforms which basically you communicate to using a serial port, and this work with it. So Alexa on wheels. Next one, empathetic and aware Alexa. So the notion out here is that these digital assistants are being in kind of their first generation. They essentially are a glorified command control voice command system. I ask them to do something, they respond. There's very little of proactiveness on their part, and certainly there is almost no awareness about the state of the person who is interacting with them. And by state I mean what happened earlier in the day, or even kind of state like the voice may be sounding stressed. So like there's a lot of work which from speech tries to extract emotion or stress or these kind of things. So kind of concept I have out here is, wouldn't it be nice if these things, these personal digital assistants were to show a little bit of awareness and understanding, like, oh, money, you had a tiring day, and kind of, or the type of music it selects is a function of maybe I had a a long teaching day today versus a light day, stuff like that. So adapts to what happened during the day or adapts to what is the current state. One simple thing to start out would be it greets, but it greets the right person, and perhaps it greets with some awareness of what was on the calendar or that day. So maybe start with that kind of a baseline. Long ago, around 15 years ago in this course, one of the students had done a project where the music on iPod or an iPod-like device was a function of what I was doing at the time. So as in, like, if I was jogging or something, or a different kind of music versus if I was chilling out. Okay, now you can imagine that, I mean, there are multifaceted functionalities that these devices do, adapt them. Okay, so that's the concept out here. You can do anything. These are just ideas. Okay, I mean, I hope that instead of literally taking these slides as they are, you kind of take them as inspirations to then define a project. Okay, so yes, you can add hardware and stuff like that. I guess the only limitation is that if that hardware is either unavailable or super costly, then it can't go forward. Okay, but usually mentally I go into these course projects with the idea that I'm willing to spend out of my own research funds around $100-$200 a project. Okay, so that's, to me, is kind of the thing in addition to whatever we may already have in the lab. Okay, so and we have a lot of stuff in the lab. So okay, next one. Complex event processing, which is a well-established field, but it basically refers to that I have multiple sources of events and I'm looking for patterns in them. And this is typically used in enterprise or data centers and things like that for warnings and alerts, like temperature is rising, and so if I have successive temperature reading which are showing a rising pattern, then I'll say, you know, that machine is warming, is having a thermal crisis, things like that. Notion out here is that imagine a space like a home or a city where there are lots of sensors, and those sensors are sending me events. It's kind of like multiple queues of events arriving, that indicating something like a camera maybe saying, hey, I saw a car, I saw a person with red shirt, or I saw Tom, and things like that. And then a backend which is ingesting these things and then looking for interesting patterns which have been specified by the user. So there are a lot of SEP systems there for these kind of enterprise use running on the server, and which let you express these patterns in a variety of ways, sometimes just as a program, sometimes using languages like SQL and things like that. So there are a bunch of these software packages. There is a GitHub link I have given which has a fairly exhaustive list of these things. What I have in mind in this project is design a SEP system for detecting spatiotemporal events from a network of distributed sensors. So one specific thing could simply be the following. I have at my home a whole bunch of Google Nest cameras, and these cameras already, together with software on Google's cloud, look for events and they send me events. And the way they send me events is through emails. Okay, it's a closed system, so it kind of sends an event. So whenever my camera sees something, I get a message like an activity was observed, or an unknown person was detected, or whatever, a specific person, because some cameras I have are newer, so they have the capability of recognizing my family members' faces. So it might say known person for money was detected, or some of them have sound, so they'll say a sound was heard, stuff like that. So those kind of events that come in. So one possible example project here is the following: write a piece of software where which monitors an email address, looks for emails from a particular source, and then I specify some recipe for extracting the event from that. So in this particular case, these events from Nest. I have similar emails coming from my security system, so whenever a door opens or something, immediately there's an email gets pushed. and then define a complex event on that. Like, for example, a very again, from in a personal setting, one thing which I often do is I forget to close the garage door. Okay, so it would be nice to just have like the garage door closed, open happened, and then more than a certain threshold has passed, and the closed event didn't happen. Okay, just stuff like that would be nice. So that's one possibility. So so you can, if any of you have used IFTTT, which is a cloud-based system, it doesn't have these notions of complex events. All it has is event action, or kind of very simple conjunction of events. In complex events, you can have notion of time and all. Another example, which sort of, imagine it's a hospital, every patient, this was a question I gave on ECE prelims just a few days ago. So I basically asked the students to design me a system where in a hospital, I can detect violations of hygiene. So if a nurse were to visit a patient and the nurse had not washed his or her hands since they visited a previous patient, then an alert immediately happens. Okay, so the previous patient could have been hours ago, and so I basically asked, kind of design me a system which kind of detects this. So that's an example of a complex event, because let's imagine I had sensors on all the sinks, and I had sensors on near all the patient beds, and I had, obviously, the nurse had some sort of device which kind of lets me know that who the nurse is, the ID, and then I can define a complex event to detect this kind of a violation and other such things. Okay, so another example would be, let's say I have cameras all over the city, and I see a suspicious car pattern. Maybe a car goes from suspect home to a federal building. Okay, and or maybe multiple such homes and are converging to the federal building. Maybe there is some suspicious pattern, so we want to warn whatever, the city or the police and first responders accordingly, or many traffic scenarios. So this notion of complex event is pretty powerful, but demonstrate it in some simple context like this. Another version of this project could be trying to do these things in a distributed setting. So the mindset here is all the events are coming to one place and your complex event software is running there. What if all I have is a bunch of devices which are independently monitoring? There is no cloud. Could they just cooperatively among them detect certain patterns? Okay, so again, sensor nodes which can form mesh networks exist. One of the latter project talks about it. You can think of doing a distributed complex event layer on top. So that's project 7. Project 8 idea is time synchronization for Bluetooth low energy. So those of you who don't know, Bluetooth has many different variants, and sort of there are variants of Bluetooth where you pair the device like your headphone or microphone, and then it streams data. And then you have these Bluetooth low energy, which are really designed for the lower data rate, things like sensors, heart rate sensors, those kind of things. Now, for these, there is, as we'll see in a later lecture, things are heavily duty cycled, and there's a master-slave type communication pattern and all. So doing excuse me, doing certain things like time synchronization and all is a bit challenging, because your underlying communication layer is kind of this weird duty cycling type of paradigm. And yet a lot of IoT devices make use of BLE, partly because BLE works across all the platforms. So particularly for iOS devices, other forms of Bluetooth like microphone and all, they require a special chip to be used, and essentially Apple only lets you pair with the phones if you pay them money, whereas BLE doesn't require any pairing for the basic data communication, so it's kind of universally used. And again, Apple doesn't require anything licensing, so you can go ahead and make a hardware device and not have to pay anything to Apple for that. So it works across both sides of the divide. So the goal of this project simply is to create and characterize a good time synchronization stack which works across devices which have BLE. And just over the past year, Bluetooth 5 has emerged with some further interesting properties, and the hardware devices for those have come out now, and your phones, like the latest iPhones and Samsung phones, have Bluetooth 5. So it would also be interesting to see what difference that has made. So this is really good time synchronization for BLE. A related project, good time synchronization for ESP mesh. So ESP286 and ESP32 are a couple of Wi-Fi modules which a company in China called Espressif came out some years ago, and these are essentially chips with Wi-Fi, and ESP32 is a chip with Wi-Fi and Bluetooth both. And you can buy boards around these for like on Alibaba Express or Banggood for like $2, $3, okay, on Amazon maybe for $10, pretty cheap. And more interestingly, some years ago, an open source community created a mesh networking layer for it. So it essentially routes packets, and also any device can talk to any device in a collection of such things. So you don't need to have a star network or those sort of things. So the goal out here is to create a time synchronization layer for the ESP mesh, so that any device, if a sensor event comes and is observed by two of these nodes, and they timestamp it according to the local clocks, but if the local clocks are synchronized, I can compare their timestamp. I can say this node saw the event before that other node. Okay, so so this is in the same vein as the previous one, except that looking in context of this. Now we'll be covering time synchronization quite extensively later in the course, but to do this project, you'll have to just jump ahead, perhaps watch my lecture from last time and plenty of literature, and then build on that. Questions thus far? Okay, next one. This is building upon that sensor mesh, but the idea now is the following, that sensors capture lots of data, and but I may not have bandwidth to extract that. So what happens is we capture data and then we detect events on it, and I talked about events and complex events earlier. So I have this field of this sensors in my home which are connected using this mesh, and maybe these are different kind of sensors, and they're detecting events and they're sending the events out. But the raw data that they capture is also of utility. It's not, in some cases, maybe I want to go back for purposes like forensics and all, or maybe diagnostics and things like that. But getting all this data out over a low bandwidth wireless link can be pretty challenging, or maybe the link is not even there. So oftentimes, therefore, delaying the transmission of the data until such time there is good connectivity is preferred. So like your phone may collect a lot of data, but only when you put it into the charging mode at your home with a good Wi-Fi connection would it actually send out the data. Or the other observation is that when you have insanely large amount of data, then extracting under a good communication link is going to be more energy efficient. And in fact, in the extreme case, you might even imagine that physically carrying the data could be better. Let's say you have to send 10 terabytes of data to San Francisco. You're probably, you can just easily drive to San Francisco and the data will reach quicker than anything that currently is an option for you. So large amount of data presents challenges and kind of requires a different way of thinking about this. So the goal in this project is that there is a sensor mesh out there, and it's sort of sensors are capturing data, detecting events, sending out the events, but they're also storing the raw data into some local persistent storage. And I'm going to extract it only when some good connection link is nearby. So like, for example, I walk there or a service person walks there and with the phone, and they have the Wi-Fi link, good Wi-Fi link, and that's when we extract the data. Now, the idea here would be that such an event may happen anywhere in the sensor feed. So that data was distributed, but we wanted to get to this route where the person is actually going to be. So there are a variety of ways one could structure. One is by default the sensor data remains where it is, and then when we have an event that a data mule, a data extractor visits the network, then all the data kind of starts flowing towards it. Okay. Another possibility is that these, in typical scenarios, there is a fair bit of stationarity. So like in a home or something like that, maybe the far-fledged sensor in my backyard I will hardly ever visit. On the other hand, the sensor which is sitting in my porch is something that I will be close to quite frequently. So maybe the network can learn what are the good extraction points and then proactively send the data there. So there are a variety of such schemes that could be explored. But the concept behind this project is how can I get bulk data out of these systems. You could also imagine that maybe the onus of extraction and all should go towards those devices which are plugged in, because as opposed to those which are battery operated. So so variety of considerations can come into play in this. So there are many different ways you could do about it. So Leon is kind of the designated mentor, but you can also, for all the projects, I am kind of by default a mentor. Okay, so as well, even if my name is not listed, but there's some ideas out here. On this one, kind of the idea would be that you would work with a system of maybe around 20-ish or so of these nodes for the mesh to be meaningfully interesting. Okay, how many of you have seen Glitter Bomb? Just one person, just two persons, just three, four. Okay, four. So Glitter Bomb was this thing in the news a few weeks ago. Okay, pretty cute. Someone from NASA. So have you heard of this concept of Porsche theft? Okay, all of you, right? Have anyone experienced it? No. Okay. In my neighborhood, it's pretty common, unfortunately, for some reason. So what this guy, this engineer at JPL, or formerly at JPL, he was pretty sick and tired. So he basically created this package which looked like as if it was from Apple or Amazon or something like that, but inside it was a pretty elaborate mechanism so that it would be tracked, and when the person opens, then glitter would come out and all, but besides that there were cameras which will take a snapshot and transmit it out. Okay, so he went to a lot of effort to make sure that whichever angle the package was opened at, still the things would work and all. And anyway, so that's the so the idea out here is design your own glitter bomb. Okay, come up with some creative ideas out here. Okay, this as sort of the text indicates would require kind of true engineering, in the sense that it's hardware, electronics, mechanical hardware and software kind of coming together, but just do something interesting out there. In the same way, so this is in terms of a package, right? And the complementary side of it is, what can the home do towards it, right? So for example, why can my home not warn me that someone is picking a package from my porch? Okay, currently it can't, even though I have a camera right there. Okay, but all it will tell me is there's an activity, and obviously I get many messages like that and I ignore it, right? But if there was a message indicating that a package was picked up, so could we design something like this to detect removal of property from home? Okay, so that's the idea out here. This again, I mean, could be based on images or perhaps based upon other sensing modalities as well. Okay, this one kind of came out of a discussion Leon and I were having. So I'm pretty intrigued by the emergence of augmented reality on our phones. Both Apple and Android have some pretty good packages. The Apple side is kind of a bit more advanced in that regard, but basically they are what we have now through these packages is the ability to overlay digital content on the physical world. And typically the manifestation in the phones is that when you are looking at the phone with the camera, so it's showing the physical world, but it is overlaying some measured information or some other things on it. Okay, so like for example, those of you who have iPhone, you can try the Measure app and you can measure dimensions of something. So that's an example. Okay, but what we could do out here is, what if you were to overlay information coming from other sensors, And an example of such a problem is detecting studs so that you can hammer things or make holes in the wall or hang things and all, right? And usually at Home Depot and all, you can buy these stud detectors, which basically are little things, and then you kind of slide them on the wall and it beeps, and that's kind of like aha, start of the stud and end of the stud, and then you can do stuff around that. What if instead I were to hold my phone against the wall and it were to just overlay the studs? And so that then I can go ahead and hammer and at the right place, not have to mark my walls and stuff like that. So the concept here would be that there is a initial phase where perhaps some sort of maybe it could be a robot which holds one of those Home Depot devices, kind of just does the wall following, observes where the transition points happen, sends that information to my phone, and my phone kind of overlays these studs, and then I can do it. And you can imagine another example. There's another project which some students had done in this course 3 or 4 years ago, was they had mapped Wi-Fi signal strength for the UCLA Wi-Fi signal in Boulter Hall, and then they had fed it into a virtual reality system, and then you could go inside the VR system and then it will show things. What if instead, now this information was just, I enter a room and geez, I mean the signal is not working, and then I just use this thing and it shows me, aha, you know, go to that corner and the signal strength there is strong. And this could be driven by historical data. So you can imagine that for a space like Boulter Hall, maybe we can maintain a spatial database, information collected by previously, we can attach it with the appropriate location, and then when I'm doing this augmented reality, fetching from that database and overlaying the information there. So being able to browse these kind of hidden characteristics, essentially you're giving a sixth sense to the humans, right? I mean, through this mechanism. So that's kind of the idea. Stud detector is just an example of that concept, okay? Unfortunately, one thing I cannot provide you are phones. We have very few of them in my lab, and they always tend to be busy. So you would need to have a iOS or Android phone and know how to program them. So. Hand gestures for smart home. So the challenge out here is that we are seeing the emergence of smartphones, but one of the challenges, how do we interact with all these kind of devices, right? Each one of the modalities that you think about of controlling things is pretty hard. Like for example, I have a lamp there and I want to tell Alexa to turn it on. Well, right now I have to remember the name of that lamp, okay, and then say, Alexa, turn whatever bedroom lamp number 1 on. Okay, it's pretty painful, particularly when things are sitting right there. So wouldn't it be nice, I could say, Alexa, turn the lamp on, okay? And so it's a combination of vocal and gestural things. Gesture alone is problematic. There are people who are exploring things where kind of point to the lamp and then kind of wave your hands and stuff like that to do different actions, and now you have to remember what action corresponded to what gesture. So explore the space of controlling smart objects in a home, but kind of both these parts, the kind of selection and the actual command. So one of the possibilities out here is that you could make use of the smartwatch kind of things to detect that and to have the gestural part, and then make use of other contextual information and hook it up with gesture. So this project is not very crisply defined, but kind of the space is this, that can I provide a better experience in interacting with devices around me without getting into the awkwardness which in isolation the two modalities have. Namely, selection is very hard among multiple devices when it is being done orally, and expressing a large vocabulary of actions is very hard through gestures alone, particularly for someone new visiting that space. So that's kind of the concept here. Vikrant and Louis are kind of the mentors out here, but you can chat with me or just directly kind of reach out to them. control is in the same vein. Control the mouse cursor using the smartwatch. Right now there are these gizmos where if I'm giving a presentation, then I can point that gizmo and kind of press buttons and stuff like that. And wouldn't it be nice if my laptop understood my gestures, and if I want to move the slide, I don't even need to be near the laptop and shouldn't have to carry anything other than the watch I already have. So can I tie together gestures being detected on my watch directly to this? New virtual sensors in AirSim. Okay, so this is a change of theme out here. AirSim is a simulator out of Microsoft, built originally on top of Unity. Unity is the physics engine which is used by a lot of video games, and it's highly programmable and things like that. And AirSim is built on top of that. In effect, it provides the ability to model a physical world like a city, and drones and autonomous vehicles and cameras deployed in it. So it has a concept of drones which are flying in that city, or cars which are driving on the roads in that city, or cameras which are at various places in that city. And drones and cars can have sensors, virtual sensors. In particular, they have cameras. So when a drone is flying, you can get a feed of images from that drone, which is giving the drone's point of view of what that simulated city kind of looks like. And people are using this thing a lot, including sort of us in my group, for a variety of purposes. For example, besides being a cool demonstration thing, it's also something where we train machine learning algorithms on. How many of you have heard of the term reinforcement learning? Okay, so fair number. So reinforcement learning, those of you who don't know, is a way to have an algorithm learn how to respond, how to do control, very loosely speaking. Okay, that's one way of thinking about it. So it learns how to observe the current state and then figure out what the right action is. And reinforcement learning algorithms do it by doing a combination of what is called as exploration and exploitation. So at any given point in time, I have a mindset that this is how I should respond, but then I'm also going to kind of explore. I'm going to try out alternative strategies, and then I'm going to learn, like for example, maybe I'll very soon learn that it's a bad idea to walk into a wall because it hurts me, or it's a bad idea to drive my car into a crowd, stuff like that. And this is a strategy which has been used very successfully with games. So this is how Google sort of on chess and Go and a whole bunch of other things, they have done extremely well. The thing though is, games are easy because you can simulate them on a computer. But when you're trying to have something learn a physical thing like the act of driving, or then you can't really, or a costly drone, you can't really keep crashing them or keep killing people to learn the hard way what the right policy is. So simulators are great out there, right? I mean, I can have many drones flying around in these simulated cities and learn kind of a baseline policy of, like, for example, how should a drone be flown. Okay, so the project out here is that AirSim has cameras, but there are a whole bunch of, it has cameras and it has IMU, which is inertial unit. So this tells me acceleration of the drone, and it has pressure. But there are a whole bunch of other sensors which are of interest: LiDARs, sound, radio signal strength. So the idea here would be enhance AirSim to create these other virtual sensors so that the overall community can benefit. Okay, so you contribute it back to AirSim, and then people who are trying to do other types of like acoustic imaging or RF imaging with drones, they can benefit, because cars and drones have a whole bunch of other sensors. They have ultrasound sensors, they have to detect proximity to things, they have radars and stuff like that. So there is a set of current sensors listed out there, and kind of you add things out on this one. Sandeep would be the mentor on this one. Tracking of assets indoors, and basically the idea out here is that in many cases there are a lot of physical objects that exist in a space. Think of an organization like UCLA Hospital, there are like tons of instruments and stuff like that and all. Moreover, these objects move through spaces. Sometimes within the confines of a smaller space like a room, or somewhat bigger space like a hospital, or perhaps even across planetary scales. So could we devise a system where we can track assets and the context they are going through? Okay, like what did they encounter? So very trivial example, sometimes nowadays when you get fragile packages from UPS or FedEx, there's a sensor attached to it, and they say if this sensor shows red, that means it has been subject to unduly high temperature, or it was dropped, or stuff like that. So that becomes kind of a protection mechanism. The idea here out would be that for specific assets, I'm interested in not only knowing what their location is, but like what all they have been subjected to. So is there a way I can collect this information, and then more importantly kind of build a database from which I can easily query? So you could think of it as things like Google Earth and all, which basically let you examine the history of a particular spot on the surface of Earth. Now this is for objects which are on Earth, but those objects are moving around. You would need to come up with some solution, something that you will attach to the objects, and you can imagine that for now we are going to consider kind of modestly reasonably biggish objects, so that you're not worrying about really tiny sizes and all, but then keep the focus on the ability to get this data, what this backend database looks like, and what kind of queries you are able to conduct on it. So the intent out here is not so much is not designing new hardware, it's really on that software layer basically. So tracking of assets indoors in a setting like a lab or a organization basically. Next 2-3 projects are on a theme that is currently pretty hot out there. So I'm sure you have heard about fake videos, right? People who are synthesizing celebrities and political figures, sort of supposedly doing something which they never have, because these are being synthesized using advanced neural networks, something called generative adversarial networks. So it's a way of training neural networks to synthesize things, and very realistic images and videos. And there was this one of Obama giving a speech. There are a couple of different ways that these are done. One is from scratch. So like I show whatever a 3D sufficient pictures about Obama, and then maybe can I synthesize from scratch a video of Obama doing something that he never did. That's still kind of far off. People are doing these things, but only small snippets, and perhaps animation movie producers are probably going to make a lot more advances there. The other one is that I take a real video of someone else doing that task and then transpose Obama's stuff onto that video. It's called style transfer. Anyway, the goal of this project is detecting fake things. So the idea is that the fake stuff will have some characteristics which are artificial. Okay, like for example, maybe the way they move, or maybe the way they blink the eyes. In fact, one of the places which had sort of come up with a solution was had to do with that the eye blinking rate was unnatural. Okay, and in fact, you can tell when you look at these videos, there's something about them is not right. As humans, you can make out that they're not quite there, but you can't pin it on it. And this researcher had said it was the eye blinking thing, and she kind of pointed that out, and then immediately the fake video people fixed it. Okay, so then kind of the reverse happened. The thesis we have out here is that perhaps there are other characteristics. So for example, a body of work in recent years have shown that by examining someone's video, I can figure out the heart rate. And the reason we can do that is because as the blood flows, there are what are called as micro blushes. Your complexion changes somewhat, okay, particularly for more lighter skinned individuals, and you can examine that, and therefore then you can know what the breathing pattern is. Likewise, there are tiny motions which are indicative of respiration. Much as you would try, it's very hard to control these aspects of your body. So again, one hypothesis, this is from me, which is that do these fake videos maintain fidelity of physiological signals. That is, would they maintain a natural physiological signal? Taking the Obama example, we have access to valid videos of Obama. Maybe you can figure out what his physiological signals normally look like, and if the fake video is drastically different, then we have a problem. So that's one example. There could be other things like that, but the notion out here is, just like we seek to detect spam calls and all, can I detect fake videos? Another one, this is a continuation of a project we tried last time, which is some work my group has been looking at adversarial inputs. So adversarial inputs to machine learning algorithms, to AI algorithms, refer to the fact that can we fool these algorithms? Can I inject something? So there's a great classifier which supposedly recognizes speech and does so correctly, except what I'm going to do is I'm going to modify the signal some way so that you will still hear it one way, but the machine learning algorithm doesn't. And this kind of work started out with images. So like you'll show the image, normally unperturbed image, and if it's a cat, it will say it's a cat. If it's a dog, it will say a dog. But then we add tiny amount of noise to it or some other perturbation, and then suddenly the human still thinks it's a cat, but the ML algorithm thinks it's an elephant. A lot of such attacks have been shown. Tiny little perturbation to the stop sign. To you, it will still look like a stop sign. You'll probably not even notice that sticker or whatever, but the machine learning algorithm doesn't see it as a stop sign. We have been doing this work with speech, so like you hear it as yes, but the machine thinks it's a no. Except all this work has been happening at the level of manipulating the digital signal. Okay, this both offers a challenge and an opportunity. So the one type of attack you can imagine is where a malicious advertisement on the TV says something, you are sitting in the room, you think it's innocuous, except that the Alexa nearby hears it as open the garage door. Okay, so could we make that happen? And it's pretty challenging because the acoustic environment, now you're going through a real world signal. So the goal out here is over the air adversarial attack. Could we demonstrate that? And therefore you will need to have a neural network or some other model which learns the characteristics of that also. And in that vein, I think I had, maybe I deleted it. Yeah, there's some other projects of this type. So go and talk to Mustafa, I guess. De-anonymization. Okay, I'm a bit above time, so let's do the following. Let me stop here. The slides are there at the URL, but I'm also going to cover them on Tuesday at the beginning. So, but go ahead and look, and also hopefully kind of things I said perhaps trigger some other ideas in you, and in that case also is perfectly fine. But start the conversation. I am yet to have anyone come to my office hours or approach me with any ideas whatsoever, so that's scaring me a bit. So let's start doing that. So write to me. Best thing is to send a private note on Piazza. I'm going to, I think at the very least you should start forming the teams immediately so that you can brainstorm about the ideas collectively. I'm also perfectly fine on things which relate to your ongoing research, your other interests, or things that you come up by reading elsewhere. These things are just suggestions which came up from conversations with my students, and you are by no means beholden. Like I said, for me the only issue is resource constraints. So if your idea requires expensive resources, then I won't be able to sustain it unless you line up those resources yourself. And the other thing is keep it bounded. I mean, we are already in week 2 or end of week 2, so you basically have 8 weeks. By the time you subtract thing, you are really looking at maybe 6 weeks of real time that you have. So you have to keep that in mind, particularly if something requires unusual resources, then acquisition of those things themselves can take time. So start the conversation with us, okay? And someone asked at the beginning of the course, what's the good team size? I would say usually 1 to 2 person works the best. 3, I rarely see 3-person projects doing things which justify a 3-person project. Occasionally it does happen, but usually what ends up happening in the 3-person project is that someone is flaking out, and I don't really want to be in a situation where then I have to deal with complaints like the partner didn't work, I did all the hard work, stuff like that. Okay, so the other thing is, don't do duplicative projects, because if you do duplicative projects, then I can compare you, and then that makes things harder. So it's good to have separate projects. Okay, so that's all I had. Have a good long weekend. See you on Tuesday.